We are now recording. It says, which of the following numbers could be the probability of an event? And we go here like this. We go, well, the probability has to be between 0 and 1. And so we go, yes, no, yes, yes, no, yes, like that. Any discussion about that? I see there's more people wearing masks. Are more people on campus now? Oh, okay. I've been on campus the whole time, but I'm locked in my office behind a plastic wall. I'm safe unless someone comes in here. Number 2, let the sample space S be the numbers 1 through 10. Suppose the outcomes are equally likely. So that means each has a probability 1/10, like that. And then, or another way to do it is you can compute probability, or probability equals number of items over 10, since there's 10 of them. And since there's 10, the probability of 2, 3, 5, and 7 is 1/10 4 times, or just 4 divided by 10, 4/10. Those are 4 of the 10 equally likely outcomes, provided I see them all. I think I do, yeah. On to number 3, speak up. If you need to speak up, please just do it. In a national survey, students were asked, how often do you wear a seatbelt when riding in a car driven by someone else? The response frequencies appear in the table to the right. Actually, it's down here due to cut and tape. A constructed probability model for seatbelt used by a passenger. And then, would you consider it unusual to find a college student who never wears a seatbelt while riding a car driven by someone else? So we're going to take this guy here. We're going to find the total. Okay. So the total of all those did I get that right? Might be, okay. So I get 4895. And then to get the probability, we'll just take the number, the fraction of the total. That should be the chance to pick somebody at random. They're in that category. So 105 divided by 4895, okay. 0215 maybe. 021, I'm rounding to 4 places. I'm not sure how much to round. Oh, round to the nearest 1,000. Sorry, I'm not doing it. I'm going all the way. I didn't do that. Okay, okay. And then rarely, 322 divided by 4895. Okay. Something is bad here. Oh, the 322 didn't happen. 322 divided by 4895. Okay. I looked at that and it was smaller than 02. 0658. 0.0658. Sometimes 517. Yeah. 517 divided by 4895. 1056. Most of the time, 1372 divided by 4895. 2803. And always 2579 divided by 4895. 52.5269, like that. Would you find it unusual to find a college student who never wears a seatbelt when riding with someone else? So this number here is never. We have 2 strategies for unusual. Unusual is p less than 0.05. We have that. And we also have unusual is more than 2 standard deviations from the mean. So those are 2 characterizations of unusual. So sometimes I'll ask you, based on a value, does it seem to be far enough away from the mean that it's considered unusual? We'd go 2 standard deviations. And sometimes they ask you a probability less than 0.05. These things don't quite line up exactly. The 0.05 is the corresponding to the 95%. Well, I guess that's 2 standard deviations. That's the empirical rule. So more or less, if you go plus or minus 2, you get 0.05, you get plus or minus 2. So we'll say, is it S? Is yes, because the probability is less than 0.05. Is that the one? Yes, because the probability is less than 0.05. Okay, I will stop recording.